Hello everyone, I am Akhila INYAS working under the guidance of Dr. E. Bojigod at CSIR and IST Thiruvananthapuram. The work is entitled as Unprecedented Thermally Induced Structural Changes in Aerosols of Poly-3-hydroxybutyric acid during heating. The polymers are divided into 4 quadrants on the basis of their origin and their degradability. Among them, this quadrant attracts more attention because these are coming from a bio-based origin and these are biodegradable. Among the biodegradable polymers, polylactic acid and polyhydroxybutyric acid possess thermal properties almost similar to that of polyolefins. Here I am preparing the aerosols of PHB by thermally induced phase separation method and freeze drying. And the wax analysis of the prepared aerosol shows that this is corresponding to alpha form of PHB. When we perform the DSE analysis of the sample, other than the double melting peak, an endotherm followed by exotherm is present in the system. The literature shows that this kind of transitions are corresponding to crystal transition in the case of polymers. In order to know what exactly happening there, we perform the variable temperature wax and Sachs analysis. Here also we can clearly see that up to that DSE transition temperature, the pattern remains same. And when the temperature reaches that 140 degrees Celsius or the DSE transition temperature, some changes are happening. Here also the peak at 20 degrees corresponding to beta form of PHB. So we can clearly say that in the case of PHB aerosols at 140 degrees Celsius an alpha to beta transition is happening, and that transition is confirmed using Raman analysis and IR variable temperature IR analysis. In the case of PHB there are two polymorphs are existing, alpha form and beta form, and alpha to beta transition is reported only in the case of highly oriented PHB samples during stretching. So here for the first time we observed a alpha to beta transition in the case of an unoriented sample by heating. So the as synthesized aerosol we named as alpha aerosol, and we annealed the sample at 140 degrees Celsius to get this alpha plus beta aerosols. So the stability of the prepared alpha to beta aerosols is confirmed using DSE analysis even after the 5 months also, that is stable, and the variable temperature wax and Sachs analysis shows that these are directly undergo melting without any further transition. So the question comes, why we need this alpha form and beta form? Almost all the properties of a polymer depends on its polymorph. Here also the beta form shows better properties. The beta alpha plus beta aerosol shows higher contact angle, and it shows better oil water separation properties, higher mechanical properties with a high Young's modulus value in the case of alpha plus beta aerosols. Both alpha and alpha plus beta aerosol shows different sound insulation properties, and the piezoelectric property also higher in the case of alpha plus beta aerosols. The alpha plus beta aerosol shows almost double open circuit voltage. Thank you.